Hello, my name is Victor Bosa, and the product owner of this project is Dr. Masoud Sadhadi. And in this video, I'm going to talk about the random forest algorithm for MQL5. You may now wonder, what's a random forest? A random forest is a robust data mining algorithm based on decision trees. And decision trees are also data mining algorithms. A decision tree takes input values and generates classes or classifications based on the analyzed dataset. These classes can be later used to formulate. Random forest then is a collection of decision trees. Let's take a look at this image. Let's say this is a random forest. All these little trees you see are decision trees. The idea is that these decision trees are going to be fed with random samples of the data set. Not all of them are going to be fed with the same data. So they're going to come up with different models. Now all these models are going to be averaged, and the average of these models is going to be the final class. Let's take a look now at the algorithm itself. The random forest is already built in the math algebra library in the MQL5 standard library. Then what we're gonna do is that we're gonna use this implementation with some agents so we can take advantage of the random forest to do some predictions. In the constructor, we're gonna initialize all the variables that we have in the random forest algorithm. This is the constructor for our agent class. In the get RDF structure is where we actually load the random forest structure that we already saved. So the first thing that we asked is if we are in the optimization mode. If we are, then we try to get the previous errors. If there are no such previous errors, then we create a new file for errors. Now, what we're always gonna want to do is that we're gonna try to load the model itself, and then with this model, we're gonna try to do some traits. The learn method, we ask if we are in optimization mode. If we are, then we are going to attempt to write the learned model to a file so we can use it later. Finally, we have the renovate policy and renovate reward methods. The renovate policy method is going to be called every time we actually perform a sell or buy operation, and we're going to keep track of the trading signals that we generate. For the renovate reward, on the other hand, it's only going to be used when the wrong the wrong signal is issued. So if the random forest gives us bad data or bad prediction, let's say it tells us to buy, and we buy and we don't make profit, then we're gonna punish it. That's the way we tell it to forget bad data and only conserve good data. We're also gonna have a collection of agents. In this case, it's gonna be a class random forest agent collection. In this class, we're gonna keep a set of agents, and each agent is gonna have a random forest. This way we can have multiple random forests working for us. In the constructor, we're gonna initialize the agents, and as you can see, we're gonna have a learn all method that is gonna be a wrap method to call agent learn for each agent. We're also gonna have a method to set up agents As you can see, it sets up all the agents attributes, right? We're also gonna have a wrapper for renovate policies. It's calling renovate policies for each agent. The same with renovate reward. We're calling renovate reward for each agent as well. And for trading signal, generate trade signal. Then here what we're gonna do is that we're gonna get all the trade signals for all the agents, and then we're gonna average them. Your next question may be, how can we implement this algorithm in MQL5? The answer is that this algorithm is thankfully already in the MQL5 standard library. And the way it works is that it's going to take historical data and it's going to generate models. And it's going to only keep the models with less errors in transactions. And this way, we can take all the values of those models with less errors, and we can average them, and this way we can generate a signal, which is a signal that we're gonna implement in our trading signal. Let's take a look at an expert advisor that is using this signal alone, and it was trained in the data from 2017 to 2018. So we run a trade test on this sample. It will take a while, about some seconds, because it opens a lot of transactions, and then we're gonna see the results. Alright, so it's ready, and then we can see that for that training that it got a very nice profit. We can also test it in different times, and the values will be different. It might lose sometimes, might win sometimes. In average, when it's trained in a very large data set, it wins about 60-65% of the times. This time it's probably my record. It won 80% of the time. But in reality, you would expect about 60% win rate in transactions, which is very good considering long-term trading. Now let's take a look at how to train the expert. There are gonna be three variables that you want to take a look at. Number of passes is the number of passes in the optimizer. I normally is about 31 steps. You can increase it, decrease it, and play around and see. But this number is giving me the best result so far. Shift probability. The bigger the value, the more transactions are gonna be. This setup with about a 0.3 stop, it's been one of the best results I've got, and as you can see, it's already lots of transactions. So we have a very good win rate and a lot of transactions, but you can also reconfigure and see if you find a better value. So regularization, it's something internal in the random forest algorithm, and it's meant to roughen the model and increase stability. And the value about a 0.2, it's the best value that I've found so far. Once we have the training values ready, all we have to do is to go to the back to the selection, and we find optimal parameters of an expert advisor using complete search. Then we select the range, and with this the range, make sure that we have optimization, slow complete algorithm, and custom max, and M15. All this setup that is in here is the best setup to train the random forest. And all we have to do is click start. Have in mind that this process is going to take a lot of time. Depending on the data set and the computer that you're using, it might take up to a day to train. So keep this in mind. Also keep in mind that it's going to take as much CPU processing as possible. Since this is a multi-processing application, it probably at some time is gonna take 100% of the CPU, so you might not be able to use the computer for other things while training the random forest. RAM is also considerable resource, but about regular RAM for today's computers will be enough to train dataset. I've seen about 2 gigabytes of RAM being used or so. So I recommend having more than 4 gigabytes available of RAM and a multi-processor CPU. Let's take a look at the signal I created for the random forest algorithm. This is the descriptor for the signal, which is gonna let us use some parameters as input. These are the inputs for the signal, which are the same inputs we have for the agents. And these are all the methods that we're gonna have in the signal. In the constructor, we're gonna initialize all the parameters and the agents. And we're only gonna have one pattern in this case, so it's gonna have 100% significance. For long condition, we're only gonna perform if it's a new bar. If we got a new bar, then we're gonna try to find for a long condition. And what we're gonna do is we're gonna get the signal, and then we're gonna do some comparison. We have an inner threshold, and we're gonna compare the signal with a magic number and a threshold. And this is how we get the long condition. Similarly, with the short condition, we're gonna have a signal, and we're gonna compare it, and then depending on the comparison, we're gonna return the pattern or not. We're also gonna have a learn function that is gonna call the agent collection learn all, and this is our signal. It's a simple signal compared to the complex algorithm, and it's working. It only needs to it only needs to be implemented for optimization, and it should be good to go. Now let's take a look at the random forest expert advisor and how it has to be set up in order to be able to use the optimizer. This is gonna be the input values, and then we need to add an agent collection in here, as well as these two variables we're gonna use for training. The first thing that we're gonna do on it is to set up the agents, and and then when we create our signal, we're gonna pass the agent collection as a parameter to the signal. Then we're gonna add the onTester method, which is included in the standard library, but it doesn't come with regular extra advisors. We have to include it. Then In this case, if it's in optimizer, what we're gonna do is that we're gonna learn, make the agent collection learn. In the init, please remember to delete the agent collection at the end. Ontick, in ontick, we're gonna add this piece of code that's gonna work only with the optimizer, and it's gonna calculate the threading signal, and it's gonna place orders orders to make the agents learn, the random forest learn. We're gonna keep the on trade and on timer as they are in the regular extra generator, and calculate trading signal is basically the same as what we have in the signal. We're gonna calculate the signal, and then in place orders is where we actually do the learning part of the optimizer, which is renovating the reward and the policies of our agent collection depending on the outcome of the trades. So the idea is that if the agents are making mistakes, we punish them, and that way they learn. Thank you so much for watching this video about random forest algorithm, signal, and extravisor. My name is Victor Bosa. Here you have my contact information, and the product owner of this project is Dr. Masood Sadhadi. Thank you so much for watching.